Look at one of the formats that a quadratic or a parabola might come in, which is the turning point or the vertex format, and that would look something like y equals k in brackets x minus a squared plus b. So we're going to start off by looking at this first parabola here. This parabola is in the most basic format. It is y equals x squared. To check that, we could do a table of values, and we could pick some values for x and find the y. So if x was 0, to find y we'd do 0 squared, which is just 0. If x was 1, we would do 1 squared, which is just 1. If x was 2, we'd do 2 squared, which is 4. We can see on the graph that our parabola, the vertex, is here at 0, 0. That's the vertex or the turning point of the graph. That's a really key feature that we need to be able to identify. Now we can see that as our graph goes across 1, it goes up 1. As it goes across 2, it goes up 4. As it goes across 3, it goes up 9. As it goes across 4, have a guess, it's going to go up by 16. And that's because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. And we know that this is going to be symmetrical, because if we went back the other way, going into negatives, negative 1 squared, well, that's just negative 1 times negative 1, which becomes positive 1. Negative 2 squared becomes positive 4. Negative 3 squared becomes positive 9, and so on. So as we move across 1 in the negative direction, it also just goes up 1. And moving across 2, up 4, across 3, up 9. So that is our parabola in the most basic format, y equals x squared. We're going to have a look now at this next one. This parabola looks pretty much the same, except that it is up higher than our last one. So instead of being y equals x squared, this has been shifted up by 1. It's got a plus 1 on the end. We could substitute in some points to help us. If we set up our table, this is x, this is our formula, and that's going to give us the y. If x was 0, well, I've got 0 squared plus 1, which is 1. If x was 1, I've got 1 squared plus 1, which is 2. If I had x is 2, I've got 2 squared, 4, plus 1, which is 5. We can see those points on the graph here, right? 0, 1, when x is 1, y is 2. When x is 2, y is 5. But when we're thinking about the turning point or the vertex format, we can look at our equation up here and think, oh, the vertex is going to start at y is 0 and at x is 0 and y is 1. It's just going to be shifted up 1 because of that plus 1 on the end. And then I think I've got nothing in front of that x squared, so it's just going to be the normal format of across 1, up 1, across 2, up 4, across 3, up 9, and so on. And the same back in the other direction. Across 1, up 1, across 2, up 4, across 3, up 9. So when we know our turning point or vertex format of the graph, that can be really easy to plot. Next one here. How is this one slightly different from our red graph up the top there? Well, it looks pretty similar, except that it's moved to the right by 3 places. How that looks, a horizontal shift in our formula will look like this. So for our green one, when it was a vertical shift, it had a plus 1 on the end. when it's a horizontal shift for a blue graph, we put that inside the brackets with the x and have that squared. And you can see that how it says -3 in our bracket here, you might be confused because that actually says it's +3, right? On our x-axis, that's +3. But the sign inside our brackets here is kind of opposite to what we would expect. So that is what it would look like. And again, I can check, is the scale factor, is there any kind of gradient that needs to go in front? No, not for this case, because I can see it goes across 1, up 1, across 2, up 4, across 3, up 9, across 4, up 16. It's got that square number pattern happening. That is just a regular parabola that's been shifted to the right by 3. And the last one here, this is a combo of horizontal and vertical shift. So we know that a general parabola would usually start there, right, on 0, 0. But it has shifted down by 4 and to the left by 2. So I know that it's going to start off by saying y equals. I can check, is there going to be a scale factor? Well, if I look at my vertex, it goes and go from there. It goes across 1, up 1, across 2, up 4, across 3, up 9. So I know that there's no scale factor to include. But there is horizontal shift. How much did it shift to the left by? It shifted to the left by 2. Remember that that's kind of opposite from what we would think, having that +2. We need to have that squared because this is a parabola. And then what's my vertical shift for this one? It has gone down by 4. And again, I checked at the start for this one that there's no scale factor that needs to go in there at the start. It's just my general parabola, across 1, up 1, across 2, up 4, across 3, up 9, and so on. So that there is my formula for the yellow graph. So if we go back up to the top here, this K represents the scale factor, kind of like the gradient, how steep is it, or that would also tell us if it's a positive shaped parabola or a negative shaped parabola. Then we've got here, this is our horizontal shift. Remember that this is opposite to what we would naturally expect. And this on the end is our vertical shift. So those 3 things I've circled in that formula are the 3 key features of a parabola or quadratic when we're looking in the turning point or the vertex method.